Off.
Yeah.
Yes.
Um, all right. Hi, everyone. Thank you so much for joining. We really appreciate your participation at the Solar Thermal Division. Today, I'm excited to have Bill Guiney here, who will talk about solar thermal applications for process heat. He is the president of Arctic Solar Inc., chair of the ASES Thermal Division, and recently an ASES Fellow. He has more than 42 years of experience in the solar industry as a retailer, solar contractor, distributor, manufacturer, and educator. Currently, Bill is the president of Arctic Solar, which is a high temperature solar thermal collector manufacturer in Jacksonville, Florida. Previously, he was the director of the solar heating and cooling business at Johnson Controls. He also served as the program director for global renewable energy development and program manager for the development of the PV solar and thermal business at JCI. Today, the webinar will provide an overview of solar thermal technologies, low, medium, and high temperature systems, and explain the industrial and commercial sectors where they are used. Solar heating for industrial process, SHIP project systems are growing worldwide. And this webinar will show how the United States has opportunities in many sectors and existing applications across the country. Bill will also review some design tools such as SAM and NREL System Advisor Model, PolySun Transient System Simulation Tool, and outline incentives for solar thermal and some energy finance programs. Thank you so much, Bill. Henry, I can give it to you for a second if you want to add anything else. Henry is our
No, I
vice
think
chair.
you covered it all, and I think we should just give Bill as much time as we can. And
Perfect.
thank you, Bill.
Thanks, Bill. Take it away.
Okay, thank you. Everybody can hear me okay?
Yes.
Okay, that's great. And thank you all for joining us. We apologize for the delay and rescheduling of this webinar. As I told Henry when I got on, some people live in areas where you get blizzards, others live in areas where we get hurricanes. So it's been a rough year for Florida, and I appreciate you all coming on board, even though we had to reschedule this presentation. So I thank everyone for attending. You know, I've been in this business for a long time. I know it well. You know, this is not a marketing presentation. This is basically an overview of the technologies that can provide significant, and I mean significant, benefit to the industrial process heating arena. Because, you know, it's something that is happening right now globally. So, everything I say is my opinion. It's not ACES. As most of you know me, you know I'm very opinionated. So I'll try to steer the boat straight and level, and not get off in a tangent like we've seen some political people doing here lately. So the thermal technologies that we're going to talk about is high temperature, mid temperature, and low temperature. We all know the technologies. They all have different applications, but all of them have applications for process heating. You know, process heating is raising the temperature of a groundwater source or return temperature, elevating that temperature to reduce the energy consumed by the boilers, heaters, and in some cases now heat pumps as well. So there's a lot going on in this business and a lot of changes happening. So we'll talk a little bit about many of them. So let me start with latest market information. I get this from Barbell. Many of us know her. You know, she's part of the solar thermal world, and Solrico. So what she's done is given us information about what's going on in the industry and where energy is being consumed by process heating applications. So you can see renewables at 12% is a pretty good take for where we are right now in the market. But still petroleum and natural gas dominate the world. And those are the technologies that we want to see reduced so we can have an impact on climate change. So this is a little busy, I guess I should say, but about 40% of all the consumption of energy is by buildings. And 40% of those buildings use natural gas, and about 10% still use petroleum. So, you know, we've got opportunities to be able to reduce those fossil fuel emissions utilizing solar technologies. I should say solar thermal technologies. So the industrial process heating industry is growing, and it's growing leaps and bounds globally, except in the United States. Although we're starting to see some changes here in the US as well. We can see 2021 was abysmal year, but that was COVID. But you can see how it jumped in 2022, and those are the latest numbers I've got available. But I can tell you, in 2023, numbers were up. In 2024, they're going to be even higher. So the industrial process heating outlook is huge and significant, you know, and it's something that we need to capitalize on. We've got the technologies. We need to go out and shop our technologies to the users so they can see what we can contribute, especially in this market today where we've got significant incentives and reasons to reduce climate issues. So the diversity is growing as well. It doesn't matter what technology we're going to talk about. They all have an impact on process heating and climate change. Whether you're a high temp, low temp, a trough, polymer collector, a PVT, an air collector as well, which does not, in my opinion, get near enough attention because air heating is very easy, especially in those northern climates that need to heat large areas. And if you look at the red, that only a few of the operating temperatures are above 100 centigrade, which means there's a lot of opportunities for technologies that don't generate steam or high temperatures, but can contribute to the process. So let's look at these issues, or opportunities, I should say. You know, greenhouse heating, drying, building, space heating, washing, district heating, which is not big in the US. It certainly is in Europe, and it's continuing to grow as well. The district heating business is very good. I was working on a project in Minnesota to provide a district heating system, but they opted for gas because the price of gas was low. So it's unfortunate. So in industry, we've got lots of opportunities from 75C or 167 and below, and all our technologies that we're talking about for the most part can generate those temperatures. And then we've got 167 to 300 degrees to be able to provide pasteurization, bleaching, dyeing, you know, and feeding into the existing heat networks, which includes process heating applications of manufacturing facilities. So every manufacturer of a solar technology has a role to play in this business, in this space.
Oh, purple ones.
So we've got, you know, low temperature, mid temperature, and high temperature applications. And each of these technologies has an opportunity to contribute. And when we look at the location of systems that are going in, the US still has a fairly large portion of the business that is being capitalized by our technologies. So commercial applications, I mean, you know, everything, you know, we can do everything. If it means heat, we can do it. So it doesn't matter whether it's low grade, mid grade, high grade temperatures, we can provide all those temperatures with the technologies manufactured here in the United States. And the industries are huge as well. I I've been in a position where I've tried to raise capital and people say, you're all over the map. You know, all these industries, where's your focus? And I'm saying, you can't really focus on a specific industry because there's so many opportunities for our technologies and business is coming to us. We're not out there seeking this business. So, you know, I've been in this business, like I said, for many, many years and done more than 250 commercial projects, and it runs the full gambit from solar cooling systems to dormitory heating to just hot water at a university on a dormitory. So there are just significant opportunities for us to continue to grow this business. When we look at the consumption, you know, and I'm using ASHRAE numbers. So we look at a restaurant, 2.4 gallons per meal. So when somebody says, we can heat your water, and if you've got a kitchen, tell me how many meals a day you serve. And we can pretty much come up with what volume of water we need to be able to provide that. What has always surprised me, was the fast food industry, 0.79 gallons per meal. So when you think about McDonald's and Wendy's and all these fast food places, they still use a lot of hot water. Office buildings is 1 gallon per person per day. Hospitals, 52 gallons per bed per day. And what's important about that is it's not the size or capacity of the hospital, it's how many beds they actually fill and service. That's what we need to design around. We don't want to design around the full capacity of a hospital. In a hotel business, these are real numbers because I've collected them myself. I worked with the state of Florida on an energy project to determine how much hot water is consumed by business hotels and resort hotels. So we can pretty much anticipate how many gallons per day a facility would use without going in and invading their, I won't say invading, but demanding data on their consumption. So low, medium, and high temperature systems have applications for commercial, industrial process heating, cooling, and process heating. Excuse me. Polymer and low temperature technologies. I've seen many systems in Mexico, Latin America, and others that are using polymer collectors to even provide domestic hot water systems. You know, we've got flat plate collectors. You know, we've got some great US manufacturers of flat plate collectors, probably some of the best in the world. We've got evacuated tube collectors, which I've got my own opinions about, which I won't share. And we've got concentrating non-tracking parabolics is what technology I manufacture. We've got CSP technologies, which is the sweetheart of DOE because it generates electricity. So DOE has been primarily interested in electricity. They don't give a hoot, basically, about process heating and reduction of natural gas. We've also got air heaters, which I said earlier. You know, there's a lot of applications for air heating. It works very good, not very good, it works very well. And we should see more of those happening because it's a passive system that provides heat for large areas. So what have we done? So I want to review a few projects that were submitted to me. You know, I have no preference on these. These have just come in from me, case studies, and these are available. This is a project by FAFCO, which is a polymer collector manufacturer in California. It was 20,000 square foot array, which is pretty good size, and a very large storage tank as well. Sorry about that. So, you know, this is one application where the low temperature technology is being utilized to preheat water going into a boiler system, process heating. Another one, here's a high school, Aztec Solar, out of California as well. It's a 324 kilowatt thermal system. They're providing hot water for a high school. And I've done schools myself, and they're great opportunities. I mean, totally, you know, when you get into the Northeast and northern area, most high schools or many high schools have swimming pools as well. Those swimming pools have to be heated. So there's nothing better than a low temperature collector to provide the heating for a swimming pool. El Paso, Texas, this is a project I was involved in, which was 8 recreational facilities. It was pool heating applications on city projects. So we did 8 facilities and saved them a ton of money and a ton of carbon offsets as well. So these projects are not unusual, and it's unfortunate that we don't have a tax credit for commercial solar thermal pool heating applications, because it's not a luxury, it's actually a commercial business, and we should find a way to include pool heating on commercial installations eligible for tax credits in the United States. So here's the senior apartment and retirement community. So I've been involved in a couple of retirement communities myself. These are 2 examples, again, from Aztec Solar in California. And they're actual published case studies that people can draw on to give them backup and support to their proposals to potential clients. Here's a business hotel here, a Holiday Inn. How many Holiday Inns are there in the country? How many Holiday Inns are burning natural gas? How many Holiday Inns are burning electricity for hot water? Those are things that, you know, we need to look at, because many of these new hotel developments are not on the natural gas pipeline. So they're using electricity for their heating, or LPG propane to be able to provide their hot water for their hotel. Solar thermal can significantly reduce the amount of energy consumed by a hotel. And the bottom one is a homeless shelter I did for Mayor Daley in Chicago. So when they moved the homeless shelter from the high rent district in the city out a little further, they developed a really green building. You can see the green roof, in addition to a significant solar thermal system to provide the hot water for the homeless shelter. So here's a multifamily, development. California has led the country in multifamily solar thermal installations, which is a really good thing. But there are many opportunities across the country, the Southeast, the tourism areas that see significant, people coming down for recreation and consuming energy like crazy. So Wellspring Retirement Center on the right was a project done by Fred Stewart out of North Carolina to provide hot water for this Greensboro Retirement Center. So, and that is an industry, again, that is growing significantly because all the baby boomers are getting old like Henry. So, there are lots of opportunities in the retirement communities as well. So schools, I've done lots of schools, whether it be a elementary school, a middle school, a university, and we have to be careful because kids don't wash their hands anymore. When they go potty, they don't wash their hands. So the water consumption is very low. So we have to be sure not to oversize elementary schools. When we get into the middle schools or high schools where they have athletics, in reality, kids today, after playing football practice, they don't shower. Years ago we did, but today they don't. So we have to make sure we're cognizant of what is their consumption of hot water, even with their athletics that are going on at the university or at the high school. So swimming pool and dining hall systems, these are some projects I did with JCI, both dining halls and pool heating. This is Fort Hood, Texas. Low temperature collectors, flat plate collectors. These are providing the heat necessary to provide the high temperatures, the process heating for the cafeterias that have both a low temperature application and a high temperature application. So Maricopa County jails is a captive audience. I mean, people are in jail for a reason. The advantage we have is these jails use a lot of energy. We have to be cognizant of them potentially having a lockdown, which means they're not going to be consuming hot water. So we've got to be able to have a heat rejection system on the large solar thermal system. The problem we see with jails is many of them are privately run. So whatever their energy bill is, they just bill the state or the municipality or the county. So there's no incentive to save energy. So what we have to do is change the laws in some of the counties and states to be able to make the private contractors save energy. So this was the St. Bride's Correctional Facility in Chesapeake, Virginia. I worked with Peter Lowenthal on this project. It was 7 systems throughout the jail. It was 252 4x10 flat plate collectors. So these 7 systems provided the hot water for this large jail. And that is a real business that can be capitalized today. Solar water heating system. This was, I think this was in Texas, yes. 84 4x10 collectors on the jail and a 25 kilowatt PV system. And when I visited this facility, it was in Corpus Christi, Nueces County. It got hurt by the hurricane as well earlier. When I was just in the audience on the tour, the gentleman leading the tour talked about the thermal system and the PV system. And he clearly said that the solar thermal system provided more energy for their jail than the PV system. And they were very happy with the performance of the solar thermal system to provide their hot water for the jail. So it just goes to show, when we compare technologies, solar thermal is still very highly regarded and can produce the energy necessary to reduce emissions and allow facilities to reduce their carbon footprints. So we've got, air and space heating systems, as I talked about earlier, commercial buildings, educational facilities. All of these have a air heating system on their facilities, providing hot air into a building in lieu of a fossil fuel generated heating system. So, you can do crop drying, you can do military applications, livestock applications as well, the chicken farmers, the dairies, all of these facilities that have to heat air to be able to provide comfort to their livestock, can be accomplished through an air heating system. And those are process heating. So here's an application that was done by Winston Cone Optics on a milking parlor in California. So their technology provided high temperature to the milking parlor, and dairies is I think an outstanding opportunity. And it's one of the systems I'm kind of focused on as well, because dairy farmers use significant amounts of energy, a lot of electricity, and a lot of heat. So they basically get the milk coming out of the cow at 110 degrees. And many of them have to lower the temperature of that milk to 37 degrees as it gets pumped into the tanker to go to a processing facility. So they have obviously significant cooling requirements, which is electricity, but they also have significant heating opportunities because they've got to sterilize and sanitize the milking parlor. It's important to provide good health for the dairy. And the other advantages we have is we can operate at a higher temperature than an electric water heater, and we can provide more bacteria reductions in their piping and their heat exchangers. And dairies get paid by the quality of their milk. So the less contaminants and bacteria in their milk, the higher the value. And if solar thermal can purge their piping and their heat exchangers of this bacteria with higher temperatures, obviously the farmer is going to benefit from a cleaner, more healthy milk and a healthier herd. So here's a case study that was done by the Renewable Thermal Collaborative. And I put the link in here because I think everybody should look at this because it's huge. It's a dairy processing facility that provided significant reductions in energy utilizing solar thermal and other efficiency measures. But it just shows you how much contribution solar thermal can have in process heating. So a couple of my projects, a bitumen tank, storage tank in Morocco. So we're keeping the tar thin so you can pump it through the piping. You know, I've done a process heating system on a honey farm, 250 degrees circulating through the facility to keep their honey hot. They have a room in the facility that has to maintain 110 degrees year round so they can pump the honey. We also provide space heating in this facility as well. So we installed a solar thermal system and a 10 horsepower LPG boiler to be able to provide his needs at the processing facility. And we were generating steam at a distillery. So we're generating about 50 pounds of steam per hour. Most distilleries and breweries need at least 300. So this is a relatively small system, but he's very pleased with it. And it's just installed in parallel. So as we're providing steam into his main steam line, his boilers are on idle. When our solar production starts to decrease, his boilers increase and provide the energy necessary to maintain the pressures and temperatures going into the facility. We've also done a evaporation of brine and an enhanced oil recovery project in Odessa, Texas. The oil and gas industry obviously is growing, and there's significant consumption of heat required for these facilities. And for every barrel of oil we pull out of the ground, we pull 7 barrels of processed water that need to be cleaned up. So we can do evaporation, we can do distillation, we can do other measures to be able to clean that water up. Some companies we've talked to are taking that processed water, cleaning it up to a standard that can be used for irrigation, which obviously in places like Texas, Oklahoma, New Mexico, and other areas that are fairly arid can use this processed water once it's cleaned up to a standard capable of using it in agriculture. So as solar cooling projects, there are many opportunities for solar cooling as well. And a lot of it is misunderstood. You don't have to replace a chiller on a building. I was involved with a project with NREL and Duke Solar in Raleigh, where it was a building that had 400-ton load of cooling. The solar thermal system provided 50 tons of cooling during the daylight hours, which meant they could reduce the energy required by the 400 tons of cooling, reduce their demand charges, and the solar system basically was able to utilize the capacity of the heat rejection units, so they didn't have a huge expense in being able to install this system to inject 50 tons of cooling an hour. And when we look at what demand charges are today, they're significant. So solar cooling, we can do ammonia absorption, we can do lithium bromide, we can do dehumidification, we can do solar assisted heat pump technologies as well. So there's many opportunities to be able to look at how solar thermal can contribute to cooling. This was Fort Bliss, Texas. There's a 40-ton solar cooling system. It was a York chiller out of Monterrey, Mexico. We used a microtrough system out of Hawaii. Unfortunately, they've closed up shop, but it did provide the heat energy for the 40-ton chiller on the dining hall. And then barracks hot water, I've done many of these systems. It just makes sense. I mean, a lot of our military facilities are in the South, which has lots of sunlight, or out in California, which has lots of sunlight. So there's absolutely no reason why we can't contribute to these applications. And the military wants to be green. They want to be able to reduce their environmental impacts and reduce their energy loads. So high temperature applications include steam, drying, cooling, evaporation, desal, pasteurization, as I talked about, and boiler preheat and dehumidification. Solar thermal can dry out the desiccant material used for dehumidification systems. So when we look at most pharmaceutical, most hospitals, all of them have a dehumidification system on it. It's very simple to be able to put in a hydronic coil on the air intake of the dehumidification system and provide the heat they need to regenerate the desiccant material. Unfortunately, many of the manufacturers don't put that coil internal to the system, so we can just put that coil on the outside of their unit and provide the heat at the intake of their unit. So when we do a process heating, survey, we need to look at, what we can do. And we cannot send steam into a boiler. It has to be a liquid. So it's got to be below 212 degrees, which means it doesn't matter if you're a low temperature collector generating 105, 110 degrees, a mid-temperature collector providing 140, 160 degrees, whatever it is, whatever your operational limits are, those preheated boilers can see significant reductions in their energy consumption. So we need to look at where the best application would be. So we've got to have site weather data. We've got to have the volume of their makeup water or reheating circulation loop. We need to know that. How many gallons per hour do we have to heat? What is the delta T or the differential for the heating system? Is it groundwater to 200 degrees? Is it a recirculation system that's coming back at 190 degrees, and we need to reheat it to 200 degrees. So we need to know what exactly we're looking to satisfy and how we're going to satisfy it. And we need to know the fuel costs so we can do an economic analysis, whether it be gas, electricity, or diesel, and determining the energy savings and the greenhouse gas reductions will help us sell these systems to the consumer. Solar thermal systems are pretty simple designs. You know, somebody asked me once, what's the difference between a residential solar water heating system and a commercial solar water heating system? And I said, it's basically just bigger. You know, solar thermal is proportional. So the savings are proportional. Whether you do a 8-hour day or a 24/7 operation, it's always proportional, you know, which is a good thing for us because it's easy to calculate. So we have the solar collectors heating our storage tanks and then going into our process heating, you know, whether we're doing, you know, process heating for a manufacturing facility, or if we're doing process heating for sanitation at a meat processing or a dairy operation. As most of us know, every single meat processing facility runs 3 shifts. 2 shifts are making steaks and bacon. 1 shift is doing nothing but tearing down all the equipment and sanitizing it, meaning chemicals and hot water. And we can provide the hot water necessary for those sanitation operations. So meat packing, food processing, there are many, many, many opportunities that solar thermal can contribute. And, you know, these are, like I said, they're just typical mechanical systems. Nothing changes. Solar collectors, circulation pumps, differential controllers, and storage tanks. So it doesn't matter if it's a 4x10 on an 80-gallon tank in Florida for hot water, or, you know, 300 square feet of solar collectors on a process heating system. They all operate the same way. It's not rocket science. It's very simple. And in this case, you can see I showed 2 circulation pumps. And I do that as a manufacturer because I don't want to stagnate the solar array. So I put in 2 circulation pumps. So in the event that we lose circulation from one pump, we don't stagnate our system. We just reduce the flow rate by 50%, but it keeps the system from overheating and causing more problems for the consumer. But again, you know, they're just very simple systems. It's not rocket science. Here's an application where we're doing a greenhouse that actually had fish as well. So they would grow the fish. They would use the fish poo to fertilize their greenhouse. So we would provide in a sump system to be able to provide heating and cooling of the fish house, because they do have to have both heating and cooling, you know, because the temperature of the water in the fish house is critically important to be able to keep the fish healthy and generating the poo necessary to fertilize the greenhouse. And then also we have the option to provide fan coil units for heating of the facility, you know, and what temperature do we need in that heating? 100, 200, you know, so there are opportunities for all of the technologies to participate in these types of systems. Pardon me. In this case, we had both a heating system and a chiller. So the chiller would provide the cooling of the fish house when necessary. In the winter, it's awful, you know, because the temperature differential, you basically walk into a fish house and it's raining from the roof. You know, all the evaporation is condensing on the roof, dripping back into the room. So solar thermal can provide a solution for that. Here's a system that I recently worked on. I think it was 22,000 gallons of hot water a day. And this commercial system, and it's not complicated, and a lot of the reluctance of contractors in the US is walking into a commercial building and looking at the heating system and going, oh my God, I've never seen anything like this before. But it's really simple. So we're taking groundwater temperature, we're doing heat recovery. So we'll do heat recovery. In this case, 2 different systems are providing preheating of that water coming in from the ground. And then it's going into a heat exchanger whereby the solar is increasing it significantly. And what we do is blend both the fresh water that has been preheated and the condensate return to come up with the average temperature in the condensation tank. So, these systems are really, really not that complicated. And, we're in this case, it required 345 of our collectors. I only used 288 in the calculations because I typically don't size systems for 100% of the load. I prefer to size the system to about 70% of the load so we don't have issues with overheating. Because if their consumption of energy goes down or their water demand goes down, we end up with excess energy, and then we have to dump it to atmosphere or have overheating issues. So my preference is to design it a little smaller to be able to utilize every BTU we generate on an annual basis. So in this case, you can see we saved significant amount of energy on this project by preheating that makeup water and blending it with the condensate return. So monitoring and building control systems and heat meters. We worked years ago with EPA to come up with a standard heat meter. These are systems are pretty much bulletproof. We can determine and calculate how many BTUs or units of energy we're saving every day. So we just put in the appropriate sensors and monitors. Every system I worked on at JCI was tied into the building control system. I don't know what their savings is because most of them were proprietary. The military does not tell you anything. You can't take any data off the base. So I'm not at liberty to say how much energy was saved or generated, but we know pretty much from the performance of systems how much energy we contributed to this project. But in reality, what we can do is provide the exact energy we're producing to a facility, and we can either do a sale of energy project, we can do a shared savings project, and all of those energy consumption and data can be used to validate the amount of energy produced by the solar heating system. So integrating a solar thermal system into a building control system is pretty easy to do. And many of the manufacturers have equipment that can tie into a building control system. So their differential controller and sensors can tie directly into a building control system. And most of the manufacturers of controllers and solar thermal systems have that technology available to them. So let's talk about how do we calculate the savings? How do we calculate the performance? How do we calculate the sizing? So there are a number of different options available to us. I'm not going to cover any of them in detail, but I do want to say that the SAM, or System Advisor Model from NREL, is pretty much the latest. It's a free desktop application, and it also will do a techno-economic analysis on a project as well. So you can pretty much, bank on NREL being a accurate and accepted application. We've got PolySun as another one, TSOL. I haven't used any of those, but I was just recently contacted by an engineer in Europe wanting to get our performance data so he could enter it into TSOL to see how the performance would be in his area. So we've got different options for system sizing, and I don't use any of them anymore, to be honest with you. I have my own, but they have been commercially available and utilized a lot, especially in Europe. Transys is the US-based system. I used it at the Florida Solar Energy Center. It's now a private company that does Transys, so they can pretty much build a performance model around your technology. So there's many different applications, as you can see, for the Transys software, which is well known, respected, and absolutely accepted by industry. So tax credits, the IRA, how wonderful was that? We saw the federal tax credit increase from 26 to 30%, and also a 10% add-on bonus for US made product. How sweet is that? So we can provide now a 40% federal tax credit on US made solar thermal systems. And you don't have to have a tax liability. You can actually sell your tax credits. So if you've got a customer that's really not interested in tax credits, you can let them know, no problem. We can monetize those credits for you. We can get between 90 and 97 cents per dollar of tax credit returned to you. You don't have to use your tax credits. You can only sell them one time. And in some cases, in the case of a farmer, unfortunately, they can take the tax credit of 40% and sell it, but they can also sell their renewable energy credit, because most of them don't give a rat's ass about energy and environmental savings. They're interested in the green dollar. So anything we can do to provide capital incentives for the project is a good thing, because somebody is going to take advantage of those renewable energy credits. So if you can sell your tax credits and your RECs, that's revenue for the project that reduces the cost. So nonprofits can also participate in this as well. So a nonprofit that does not owe federal income tax, they've got some requirements that they have to do. They have a pre-filing registration process whereby they have to actually file with the IRS to let them know that we're going to take tax credits on a solar thermal system or a solar PV system. And then the sweetest thing right now is the USDA renewable energy credits and loan guarantees. A loan guarantee of 75% of the project costs and grants up to 50% of the eligible project costs. So when you add the 40% federal tax credit and a 50% grant from the USDA, what is that number? 90% of the project can be covered by the feds. And then when you calculate the energy savings, in some cases, farmers and dairymen can see a positive cash flow in the first year. All we have to do is make sure we find bridge financing to be able to get the system sold and allow the farmer not to dig into his pocket, because most of them, their pocket is in the back 40. So they don't really want to draw on their own cash. So if we can figure out a way to finance the tax credits and the USDA grant for the farmers or agricultural applications, these could be a significant sale for the solar heating industry. You've got to be a US citizen and you've got to be located in a rural area. And what's really convenient is the USDA has a website where you can sign on, put in the zip code, and determine whether or not that area is eligible for the grants and the loan guarantees. So what I'm asking is, I want everybody to join the ASES Solar Thermal Division. You know, we are a very small group. We're very much overwhelmed by the PV industry today, but we have a lot to contribute, and we need to start barking our tune and let people know how much energy we can save and what the contribution is to greenhouse gas reductions and emission reductions in the United States. So what I'd like also is to have companies volunteer to host an educational webinar on your products or technology. You know, this is not, as you could see, a technology or company focused presentation, but we would be open to allow companies to present their technology to educate us more about the options that are available to both contractors and consumers in the United States. So if you'd like to be able to do a webinar with ASES, please let me or Henry know. So I thank you for your time. I think we have a little bit of time for Q&A. Ella, thank you.
Thank you so much, Bill. That was incredible and so informative. Let's do some, in the last 8 minutes or so, let's do some questions. I saw a few from Drew come in, so I'm just going to go through the chat. And then afterwards, since you all have the ability to unmute yourself, you're also welcome to do that. But before that, let me just double check. So Carlos said, who is monetizing tax credits? Do you mind explaining a little bit more about that, Bill?
There are a couple of companies in the United States that are buying tax credits. I've been working with Sterling Planet in Atlanta. They will buy tax credits. They also sell renewable energy credits. So that's basically what their business is. And I was recently contacted last week by another company that is buying tax credits, but unfortunately I don't recall the company name. I've been so busy working in the plant that I haven't been able to respond to them. But there are companies out there that will buy federal tax credits.
Amazing. Thanks so much, Bill. And Drew says, IRS will send check to nonprofits for 30% of solar cost. Does anyone know who has actually gotten such a check 2.5 years in now?
I don't know of any, Ella, but Drew is, a mover and shaker in his business. He may be aware of some, but what we would like to do is if you do have information about companies that have successfully done this, let me or Henry know so we can log it and promote it as well.
It would be a great thing for a brief part of a webinar to understand the financing and the success stories that people have.
It would.
Great, thanks so much. And Thomas Fisher said, what was the name of the coil? This was about 30 minutes ago, so I think this was back in your presentation.
That's okay. There are a number of companies that manufacture hydronic coils. So they basically will do the sizing for you. So they'll need to know what the flow rate requirement would be to generate, like in a case I worked with 3M on one of their manufacturing facilities. Actually, it was a mine in North Carolina where they were mining the aggregate they use on roof shingles. So they had drum dryers and they had air intake, and then they use fossil fuel or gas burners to provide the heat for their dryers. So basically, we asked the coil company to size coils to be able to provide X temperature increase, and they would tell us what the flow rate requirements would be. So they work right along with you. So they're just hydronic coil manufacturers around the country that can provide those solutions for us. In many cases, they're not a packaged coil, so you'll have to do a little fabrication of putting the coil in a box and being able to attach it to the air intake of a system.
Thanks so much. Daniel Simon asks, I'd like to confirm that the DOA REAP, R-E-A-P, and DOE ITC add together.
Yes, absolutely. They're both
Awesome.
separate, standalone, opportunities for rural agriculture, and I won't say just agriculture, rural businesses. So if you're a business in a rural area, you can take advantage of the REAP grants and the REAP financing.
Thank you. Brett asks, can you provide me the sample permit plan to know more about the system?
What do you mean by permit plan? I don't understand. I mean, we have, lots of us have system designs. So basically any manufacturer you contact, they can give you a one-line drawing of how their system integrates into a building or the application. So if anybody has, more questions, they're certainly able to contact me directly, and I'll either provide that information or steer them to the manufacturer that can supply their solution.
Thank you. Awesome. Last couple of minutes here. Mark Baker asks, years ago, there were many small companies that made solar water heating collectors, 20 in Oregon alone. Now there are very few companies, and the best flat plate solar collectors appear to be European manufacturers. What solar hot water products do you use, and what price are you seeing for high plate solar hot water collectors per square foot?
I totally object to the comment that European manufacturers are better. The United States manufactures very good solar thermal technologies. They have advanced manufacturing technologies. They have high performance. True that we don't have as many manufacturers as we used to have in this country, but we have some of the best solar thermal technologies available globally. And that's bottom line. Anybody that says European technology is better is not correct.
Thank you so much. Paul asks, does SAM do an hour-by-hour simulation of solar thermal systems?
I don't recall, but SAM is a very, I won't say complicated. It's a very intense calculation product or software. So the people at NREL and associated with SAM will provide significant, how would you say, support for anybody that's utilizing the technology. I currently don't. Well, I won't say that. I do. I use it all the time, but I don't use it to its fullest capability. I use it for components that I integrate into my own sizing systems.
Great. Thank you. Mark also asks, please send some names of good US solar hot water manufacturers.
Well, there are a number of them, and I know there's SunEarth, there's AET, and others, which are probably the leading manufacturers of solar hot water collectors in the US. And they have a plethora of system sizes, collector sizes that can be utilized. And they're all very well made. They're using, modern technologies and advanced manufacturing technologies.
Okay. Last but not least, this will be our last question. Thomas says, you have talked a lot about the benefits and opportunities of solar thermal technologies. However, these technologies have still not taken off here in the US. Why do you think that is the case? What are the main factors that are contributing to the lack of growth in this industry?
Primarily, it's low natural gas prices. which is not a bad thing. You know, it does hurt the economics, which means we probably could utilize some more incentives, especially from the gas industry, if they get serious about reducing their own carbon footprints. The other thing is financing as well. We need financing for solar thermal systems. It's easy to get PV financing today because it's a huge market, and the solar thermal market is significantly smaller. Unfortunately, it hasn't always been that way. You know, the solar heating industry started SEIA. So, you know, it's like we've taken a back seat to PV, but it's not necessary. And if we can find the right financing instruments, and there are companies that are out there that do that. There are companies that provide leases. There are companies that provide leases that integrate tax credits and monetize those in the lease. So there are different options available for financing of solar thermal systems.
Amazing. Well, we are out of time. Thank you so much, Bill, for your incredible presentation, for your time, for being an amazing chair for the Solar Thermal Division. Thank you all so much for your participation, and please feel free to continue the conversation on the ASES online community. I will, as long as Bill's okay with it, send his slides out to everyone. I know quite a few people are asking for those, in addition to the recording. So thank you all so much. We will see you soon. Have a good rest of your day.
Thank you, everybody. Hey, Tommy, how you doing, bud?
Bye. Thank you.
Thank you. Good night.
Good night.